Okay. So next week's your first test. We'll review on Monday. The review test is already in Hawks, so you can do that as many times as you want. Basically, on Monday, I'm going to go over that test. I'm just going to go over the review test. On Wednesday is the test. It's basically the exact same thing, just going to have different numbers and stuff like that. You're going to need to use a computer to do it, so you can either use the computer that's sitting in front of you, or you can bring your own. Either way is fine. I will have the calculators that you're going to be able to use on my website anyway as part of the review. So you can click on my website to get any of the calculators and go directly from there, so you don't have to search for them. Yes? So the physical calculator is fine, except it doesn't have like the standard deviation and stuff like that that you can use on it easily. So these calculators will do specifically the things that you're going to use. So that's going to definitely help you. You are allowed one index card on the actual test. So my suggestion would be, while you're going through and doing the review test, if you have to look things up, write that down on the index card, because this way you can have it and you won't have to look it up for the test. I should be here. I can be here at 1:30 on the next Wednesday. Yeah. So I'm normally upstairs. I just came down a few minutes late. So, but I will definitely be here for 1:30 on next Wednesday, so you can get in here and start the test earlier if you want. As soon as you're done with the test, you can go home. You're done. So, okay. Any questions on the test next week? I highly would suggest doing, if at this point you're behind on the homework, I haven't actually looked, I would focus more on the review test than doing all the homework at this point. Okay? Make sure you study for that test and then go back and work on the homework afterwards to catch up on that. So, all right. The last two sections we're going over today, we're going to go over 4.3 and 4.6, so the end of chapter 4. First thing we're going to talk about is percentiles. How many in here took the SATs or the PSATs? If I had asked that question 3 years ago or 4 years ago, everybody would have. Things have changed since COVID. All right, so the percentile, when you took those tests, one of the things you get back is a report telling you which percentile you're in nationwide. So you're either like the 50th percentile, 70th percentile, 80th percentile, or whatever else. So the percentile tells you what percent of the data is less than or equal to that. So if you are in the 80th percentile, that means you're above 80% of the population that we were looking at in that respect. Okay? And then obviously the opposite, 20% would be higher than you in that respect. Depending on what you're talking about, depends on what percentile would make sense for that. If you're looking at the SATs, you want a high percentile, because that means you're smarter than most of the people that took the test. However, this is one of those charts that you typically would see. Oh, that's why I did that. So this is a height and weight chart, or a weight chart actually, for babies. And we can see, it does nice. Hold on. Zooming in on the wrong thing, and then it won't let me do what I want to do. So you can see over here, the 98, 95, 90, those are the percentiles. So in essence, you really, truly would want to be right in the middle, right at 50%. That means you are average for your weight for your age. Okay. If you're up here, it means you're heavy for your weight for your age. So this is one of those places, actually probably one of the first places that in your life you actually see percentiles. Not that you're going to understand them or remember them at that age, but that's one of those first times where your percentiles actually truly matter. And it's the one time you don't want a high number. So it's that piece of information there. So and actually, depending on how old your parents are, some parents used to actually save these. Like, I know in my baby book, I actually have this literally in my baby book from when my parents would go to the doctor with all the information written into it. Now everything's digitally, so. All right. So to find your percentile, a little nice little flow chart. So your percentile, finding your percentile, first thing you have to do, just like we did for median, all your information has to be in order. Okay. To find the location of the percentile or the piece of that information. So like if I wanted to find the number that is in the 50th percentile or 75th percentile, first thing you're going to do is you're going to take that percentile and change it to a decimal. So this piece right here, all that does is change 75% to 0.75. Okay, so you don't necessarily have to worry about dividing by 100. Just you want it as a decimal, not as a whole number. And then you're going to multiply it by how many people that are there or how many items are in the list. Okay, so it's the number of items in the list times whatever percentile is. And that will tell you the spot in that list. So for median, what would be the percentile for median? Not a trick question. 50. Because it's the middle, right? So the middle would be 50%. So the median would be your 50th percentile. So if you have a list of numbers, if you have 100 numbers, and we look for the 50th percentile, we just multiply that by 0.50. We're looking for the 50th number. So you can easily count over instead of like we were doing last time, counting in. All right, what happened when we had median and we had two numbers in the middle? You have to add them and divide by 2. So the same concept appears here. If this number comes out to be an integer, an actual whole number, okay, you're going to add that number with the one next to it. All right, so if we had 100 numbers and it was the 50th percentile, it would be 50. We would take the 50th number and the 51st number, add them up and divide by 2. If it comes out to be a decimal, you're just always going to round up, and that's the number you're going to take. So for example, if I had 99 numbers and I'm looking for the 50th percentile, it'd be 49.5. I would round up and I would take the 50th number that's in that list. You always round up. Even if it was 49.1, I would round up to the next number and take the 50th number. Okay, so always round up. And that gives you the location of the data. Yes.
What letter is that supposed to be?
It's like an L. It's a stylized L for location. All right. Let's actually do one. All right. So the 50th percentile of the following data spelling error is found on 7 pages of a website. What's the first thing I got to do to these numbers? Yes. Very good. So now they're in order. All right. So we're looking for the 50th percentile. So I'm going to take the number that I have. So it's 7. And multiply it by 0.50. Which gives me what? 3.5. Is that an integer? Is it a whole? An integer is just a whole number, by the way. Is it a whole number? No. So that means I round up. So I'm picking the 4th number. 4. So that is my 50th percentile. Okay. 50th percentile, yeah. That's the same as the median. What if I was looking for the 80th percentile of this one? Yeah.
the, 0.50 with 0.80.
Yep.
Calculated for, that was easy, it was 7 and 9, yeah.
5.6. 7 times 8.
Oh, right.
So we're going to change. This is not an integer as well. So we're going to do what? This goes up to 6. So I pick the 6th number. So this right there, that's my 80th percentile.
If that number did good, not the.
Correct.
Okay.
That, yeah, that's not the number. That's telling me the location that I'm picking. So I'm picking the 6th number in that respect. Okay. Simple enough? Okay. They're in order. Can't make it bigger. That's fine. All right. I want you to find me my 10th percentile. For this one. So how many numbers are there? 40. So I'm going to take 40 and I'm times it by 0.10, which equals 4. All right. That's an integer, right? So which two numbers am I going to take? Right. I'm going to take my 4th number and my 5th number. Since it's an integer, I take the two numbers that work with that. So the 4th number and the 5th number. So I would take those, add them up, and divide by 2. So 28 is my 10th percentile. All right, if I'm in my 88th percentile. So we did 40 times 0.88. What was it, 35.2? So 35.2. So the key with this is why this one's important. You always round up. Always round up. Yes, technically by correct rounding rules, we would round down. But since we're looking at we want the 88th percentile, if we round down, that means it's actually going to be less than that. We would rather it be more. Okay, so we're always going to round up. So we're going to take the 36th number in this case. 10, 20, 30, 4, 1, 2, 3, 4, 5, 6. So 73 would be the 88th percentile. So you're always going to round up in this respect. Yes.
Why do we do that with the whole numbers?
Why do we add the two together?
Yeah, why do we average?
So because when you're looking at the exact when it comes up to be the exact number, well, think about it. If it was 4, what was the number? 4? Yeah. If it was 4.1, I would pick which number? Right. So because it's exact And again, I want the numbers to be split so that the 10th percentile is below 10% is below, or yeah, 10% is below and 90% is above. So if I chose the fourth number, it actually makes that uneven in that respect.
Oh, okay.
So it'd be like if we're looking for the median, and I picked out of the 100 numbers, and I picked the 50th number in the list, there'd be 49 numbers before it and 50 numbers after it. So we want it to be exactly in the middle. All right. So what we've been what we've been doing is I give you the percentile and we find the location of it. We can also do the other direction. If you know your number out of the total, you can figure out what percentile you are in that respect. So the percentile of a number is the number of values less than it divided by the total number of values. Okay. So it's the number of data values less than or equal to it divided by the total number of numbers. Yeah, that just changes it to a percent. It's the same concept of like, and there's a lot of different ways to write a percent. And it really depends on what you're using the information for afterwards. So like if you say it's 0.75, you're automatically gonna say that 75%, most people know that. So when you see the times 100 and the divide by 100, it's literally just shifting decimal points. So I wouldn't stress about that piece. All right. Let's take 46. What percentile is 46? It's the 15th number, right? That's not the percentile, though. That's the location. So there's 15 numbers, either less than or equal to that number, right? So I would take 15 and divide it by how many numbers total are there? 40. So I would take those two and divide them. And I get what? That I need to use a calculator for. So it's the 38th percentile. Yeah. These you could actually round correctly.
Oh, okay.
And in some cases, you could actually just leave it as 37.5 percentile, but I typically round them to just two decimal places.
Is it 15 or 14? Did you include that number?
Yeah, because it says less than or equal to. So in that respect, you'd add the 46, which would be 15 numbers. Okay. All right. We have 3 special percentiles. These percentiles are known as quartiles. We've already talked about one a few times, the 50th percentile, which is your median. The other two are the 25th and the 75th. Okay. So what this does is it splits your data into 4 equal parts. All right. With all parts having the exact same number of values in them. So the 25th, 50th, and 75th percentiles are known as the quartiles. You will typically see them listed as Q1 median, which is Q2, and then Q3. So 25th, 50th, and then 75th. All right. The next piece, yes.
there any kind of shortcut to the sub number, like next to the Q, or?
Oh, to write it or type it?
Yeah.
Depending on,
See what's gonna come up a lot.
it's not actually, because they'll actually give you the information. They'll say Q3 equals and they'll give you the box.
Okay.
Depending on the actual calculator, sometimes if you actually put a letter and then type the number next to it, it will automatically put it down below.
Wow.
In Word and stuff like that, there's actually an option to click to put it down below the subscript. But no, in the Hawks program, it's never going to have to type in Q3. It'll say Q1 equals Q2 equals things like that. So then you just fill in the blanks. Interquartile range. We talked. What's range first of all? Remember back. Correct. Largest and the smallest. All right. So interquartile range is going to be that intersection. So it's going to tell me the difference between Q3 and Q1. All right. So it's going to give me that piece in the middle. So if we're looking at a set of data, why would I want to know the interquartile range as compared to just the overall range? What would be one of the benefits? Well, what's interquartiles from the 75th to the 25th, right? So we're splitting it into 4 equal parts. So every part has the exact same number of data points in it. So what would happen by cutting off the 2 ends?
Get rid of outliers, right?
Yeah, the ends are going to be where your outliers and stuff will fall into place, right? So your interquartile range, that middle piece, might give you a better representation of how spread that data is. You also typically will have, the more data you have, you should have that middle piece be pretty standard or pretty symmetrical. Yeah.
Is this use case kind of similar to what we use median? Like,
Yeah, it's just going to give you another data point in that respect. All right. Same set of data. Find me my 25th, 50th, and 75th percentiles. Yes.
so the location are 10, 20, and 30, which means the values are, you could just hit the, yeah, those two.
So the first one's going to be that 2, right? So it's 41 plus 43 divided by 2. 42. So that's Q1.
The next one is 2 of the same value, so it's 54, right?
Yep. So those are the same. So that would be 54, and that's my median for Q2. And then I have 64 and 66, which will give me 65, which would be Q3. Good. So what's my interquartile range? All right, what do I do?
You subtract 42 from 65, which is 23.
So 23. So that would be my interquartile. It's 23. And this is a good thing to think about, like why we choose 2 numbers when we pick them. Because the goal, if I'm splitting the data up, it's 40 numbers, right? So each quarter should have exactly how many numbers in it. I'm splitting it in 4 equal parts. 10. So if I had chosen 41 as my middle number, there's only 9 there. So by choosing the number in between those two, I now have 10 numbers there. I have 10 numbers there, because even though that 54 is there, the 54 I'm choosing is actually between those two 54s, even though it's the same number. So that's how it splits it up into 10 equal or numbers in each equal section. Good. Simple enough? Okay. Has anybody seen this before? They call it a box plot. I have always called it a box and whisker plot. So the difference is these are the whiskers. So it looks like the whiskers on the side of a cat. So this type of graph is known as a box plot or box and whisker plot. And it's part of the 5-number summary. It allows us to display the spread of the data and how like either compressed it is or spread out it is using a graphic representation. The 5 numbers are quite simple to get. It's Q1, Q2, and Q3, which we just did. And it's the minimum and the maximum. Those are your 5 numbers. Okay. So for the data that we were just looking at, we found that was Q1, that was Q2, and that was Q3, and then that's my min, and that's my max. Where's the interquartile range represented? Yeah. Yeah, the box is my interquartile range. All right. So when we're looking at this, remember, each one of those sections has how many numbers in it? How many numbers was in each section, in each quarter? 10. So when we're looking at this, there's 10 numbers here, there's 10 numbers here, there's 10 numbers here, and there's 10 numbers here. You can see how each of the quarters are spread based on the lines in the graphs. Okay, you can also see that the center 20 is more compressed than even like the first quarter completely. Okay, so you can start to see how that data is spread out and organized. So that's a box and whisker plot. Let's see, hold on. Yeah, let's do this one. And then we'll actually do it. All right. Outliers. Remember I said we're going to come up with an actual definition of an outlier? An outlier is 1.5 times the interquartile range above the 75th percentile or below the 25th percentile. I need my interquartile range. Hold on. You stay there. Where's my other one? Oh, it went all the way to the end. What? All the way to the end. I'll go back. Give me a second. There we go. Okay. There. Quartile. Yes.
So would it be would an outlier have to be greater or less than, not greater or equal? Like,
yes, it's not equal to. So your low end, you're going to take Q1 and you're going to subtract 1.5 times the interquartile range. Your high end, you're going to take Q3 and you're going to add 1.5 times the interquartile range. All right, so let's look at this data. Actually, see if that's there. All right, so my interquartile range is 23. So my low end outlier. So actually, let's find the outlier number first. So I'm going to do the interquartile range, 23, times 1.5, which gives me what?
34.
34.5. So now the low end, I'm going to take Q1 and I'm going to subtract 35.5 or 34.5. So it's 42 minus 34.5, which is 7.5. Yes? Okay. So are there any numbers lower than 7.5 in this set of data? No, so there's no outliers on the lower end. My high end, I take Q3 and I add 34.5. So I'm going to take 65 plus 34.5, which would be 99.5. Are there any numbers higher than 99.5? Yeah. So this problem in this set of data, I have no outliers. Okay. Okay. So oh, I like that one. We'll ask that question. What's the level of measurement of this data? Good review for your test. Yes.
I know it's quantity.
Okay. Because it's numerical.
Yeah.
All right. So that means it's one of two, right? What are the two that it can be then? Interval or ratio. All right. So is it interval or ratio? Because this matters. Because if it's not, if it's only interval, like we're going to do some calculations with it. So if it's not ratio, we can't do that. So in this case, this is a ratio. Because if you think about, we're saying higher than or lower than, which is in essence what ratios do. So, all right. Take this data, find me my first quartile, second quartile, and third quartile. Which means the first thing you have to do is what?
Put them in order.
Put them in order. I really wish I had an easier way to tell you to put them in order. I don't.
Are you good at using Excel?
Yeah.
So isn't there a way to like copy data? Put it in
Yeah.
Excel?
So the problem
Obviously,
is,
this application I can't. At home, I was trying to. I don't
so in Hawks, there should be a button, and
know. I pressed it and it copies it.
copies it.
Yeah.
You should be able to just paste it directly into Excel.
Yeah.
Which should put it
I
in
got it in, I
Excel.
just didn't know how to order it.
If you select them all, there should be a button up on in the toolbar that has like basically like an arrow to sort the data. You should be able to highlight it all and sort
Highlight
it.
it all first.
Yeah, highlight it all and sort it. You can do the exact same thing in Google Docs or Google Sheets. So you don't. That's typically the easier way to do it. Yeah. Yeah, but unfortunately, I just wanted to. Like, unfortunately, there's no easy way around this one. I probably should have done it all myself because I'm gonna have to do this problem on the floor for a second.
This part, so far.
Let's see. That's what it-
There's a total of 26 values. I think.
Oh, how nice.
Did it.
That's helpful.
There's 26 values, right? Which one? So
30.
30?
Yes, there's 30 numbers.
Oh, yeah.
Yes, 30. All right, so there's 30 numbers. So we're taking 30 and I'm multiplying it by 0.25, which gives me what? So I'm taking my which number? I'm not taking my 7.5 number, taking the eighth number. Okay, so that's the eighth number. So 1, 2, 3, 4, 5, 6, 7, 8. So, yeah. So that is Q1. So Q2, 50 or 30 times 0.50. It's 15, so I'm going to take the 15th and this 9, 10, 11, 12, 13, 14, 15, and 16. So Q2 is there, which is 61. So 40, 61. And then Q3 is 22.5.
Yeah.
So it's 23. So 16, 17, 18, 19, 20, 21, 22, 23. So Q3 is right there. It's 84. All right. Any questions finding those? Yes.
Sorry, can you, so you just count?
Yep. Once you get the number, you're just literally counting. Now, I will say if you had a list a lot longer than this, like if you had hundreds or thousands of data points, you're not doing this by hand. Excel actually can do this for you automatically. It finds you all the different data points, the Q1, Q2, Q3, and everything else. And there's calculators online that can do it as well. But trying to just like when you're doing it like the little ones like this, it's just understanding what it is and why like those numbers exist and how it's split up. So, but yes, just counting. There is no way to take the data and do a calculation to get the actual number that's in it. So like just like there's no way like we can find the average or the mean, but there's no way to calculate the median without actually counting in the numbers. So the quartiles and percentiles are the exact same thing. It's just you have to count it. It's going to tell you where it is, but you still have to look at the actual data to find out what number represented that is. All right, so why would these numbers be important in terms of this study? So why would somebody care about these numbers? Yes. Well, what was the study doing? Yeah, it was a test to see how well they actually paid attention to the show, right? So it'd be like a test at the end of it to see how much you actually paid attention to it, or if you were just playing and surfing on your phone. All right, so what's the 61 represent? We'll assume this is a normal test that you normally would take, so 61 would be the percent of the questions they got correct. So if 61 is Q2, that means that what? Half the people scored would have basically failed this test. Which means one of two things. They either didn't pay attention to the film well enough, or the questions were way too difficult to start with. And actually, a lot of times, I'll tell you, like, I'm going to go, I'm just like, not a lot of teachers. Your math teachers and your science teachers will do this. Your English teachers and social studies teachers will not. What I used to do at the end of the semester is I would take all of my students' grades and do this to it, just to see where the pattern was. Like, and I knew what I expected to see, and if I didn't see that, then I might have been too hard that semester, or it might have been too easy that semester, depending on which direction it was. My goal was always to have my Q2 right around 75 to 80. That was my goal. So you can start to look at, okay, well, maybe this test was a good test, or maybe in this case, maybe the test was too difficult for what they were asking. So you can start to get information from it. All right, what's the interquartile range? Which two numbers are we subtracting?
84 minus 40.
84 minus 40. That's okay. 84 minus 40 is what? 44. So my interquartile range is 44. All right. Do I have any outliers? What's 44 times 1.5? Way more than 40. Okay, so I know I'm not going to have it in the low end because I'm going to have a negative number, right? And if I went and added it to 84, I'm going to have more than 100. So we know there's no outliers in this data. All right. So this is a graph using a box and whisker plot. So this gives us some information. These numbers up here, that's how you'd represent an outlier.
Dot outside the normal range.
Yes, it's a dot outside the normal range. So when you're looking to show outliers, we would put the max of our interquartile range that we did it. That would be that new line there. So that's not the actual maximum of all the data. That is the maximum of my interquartile range when I multiplied it. So that'd be the highest I could possibly go. Then you'd put dots to represent any other points after that point. You can use dots. Some people use stars, things like that. It's like outside of the actual normal, that's how you'd represent your outliers. In this case, they only put one dot. There's probably a lot more than that, but they only put the one dot there. This one's also got the X in the middle here. What do you think that represents? There's only so many things I've taught you so far, so it's got to be one of the things I've told you. Take a guess. Well, what's Q2? Q2 is the median, right? So that would be the line. That's Q2. So not the median.
The range, the 70, like the 50th and 75th percentile. Like that's what they're looking.
Nope. It's an actual calculation. What's the other calculation that we can do on a set of data? Nope, you had your guess. The answer robot is closed today. Now you have to think she's already gotten her guess. So therefore somebody else has got a guess. What's left? Exactly. There's only two other options you can give me. Nope. That wasn't one of the two options. Interquartile range would be the Q1 minus Q3. So that's not going to give me a number in the data set. What are the three measures of central tendency?
Where the mean is.
That is exactly where it is. That is the mean. Mean, median, and average, and mode, right? Mode just tells me which one's going to appear most often. So that's probably not going to be marked like that on here. So it's either your mean or your median. Median is the line. So it has to be your average or your mean. So, and the outliers, you can see, pull it towards it. So you can start to see how the outlier pulls the mean above the median. Yeah.
With that X, it's like, which point of it is average? Like the middle of the X? Or
I would say the middle of the X. But you gotta remember, when you're looking at a graph or like a picture, they're not always exactly accurate in terms of it. It's just supposed to give you a visual representation of what's going on. Okay. Did you ever hear that concept of you go to school, you get better jobs, you make more money?
supposedly.
Okay, so let's look at this. So these are box and whisker plots for your education and earnings in 2016. So is there a possibility that somebody that is earning less than that did not graduate high school is making more money per week than somebody that has a doctorate? based on this data that I have on the screen? How can you tell me that?
Guess I'm considered outliers. but
There
that's
is no
not-
outliers in
that's
this.
not on the chart,
There's no outliers in this.
according to this, no.
You have to look at just the data that's on here. So we know that that point right there, that point, that's the maximum of the high school diplomas, right? That means somebody has earned that. And that is above the minimum of the advanced degree. So there's a possibility that somebody that doesn't have a high school diploma is earning more than somebody who has a master's or a doctorate. Okay. Now, that is an extreme case, but it does go to show you, like, even if we look at, like, if you look at Q3 of graduating high school, okay, that means that there's 25% of the people above that point. And that's falling into a decent amount even in the other degrees. Okay. So while what this graph shows is that, yes, on the high end, you can definitely earn more, but you're not guaranteed that. So, yes.
I noticed as the degrees get bigger, so to speak, the whiskers get longer.
Yeah, the whole thing gets bigger. Right? So it becomes a lot more spread. So, and a lot of that has to do with what your degree is in. Right? If you're going into an engineering degree and you have that, you're probably going to make a lot more money than somebody that's getting a philosophy degree. Okay. So, like, that's the thing. When you get higher up in those respects, it's going to be a lot more spread because you have a lot more variation in what your job careers and stuff would be after that point. So, and yeah, so definitely on the high end, you can get, but that's not always going to be the case. So this is just an easy way to represent and see that spread and how we look at a box and whisker plot. All right. Next. Proportions. So a proportion is a measure or a fraction of a group that possesses some characteristic. These are some of the symbols that you're going to see when we're working with proportions. So these are the two that we're going to look at quite a bit. These two down here. So when it's just the P, that is the population proportion. So that's if we have all of the data. When it's P hat, when it's that P with that little caret symbol above it, it's called P hat. That's the sample proportion. Right. So whenever you see the P, we're going to be talking about proportions. And as crazy as all it sounds, it's actually very, very simple. What proportion of the class is left-handed? How do we figure it out?
We take the 4 who are left-handed divided it 5, yeah, 48.
That's it. That's all it is. Somebody do that really quickly because I don't feel like picking my phone out again. 0.12. No, it's you did it backwards. 0.08. Yeah. I was gonna say if you got 12, you did it backwards. Remember, the proportions should always be less than 1. It's going to always be between 0 and 1. So 8.3%. That's it. That's all a proportion is. Yeah.
Because it mentioned it was a fraction of the group, should we leave it as a fraction?
You can leave it as a fraction or you can change it to a decimal. It honestly depends on what you're using it for.
So 1 and 12 versus.
Yeah. I prefer fractions. However, again, it really depends on what you're going to use it for. I like fractions because they're exact. So if we're going to use that number again in something else, if I use the 1 over 12, I'm going to get an exact number when I do the calculations out later. Where if I use 0.083, I might get a different answer than if I use 0.0833333. I do not know what Hawks actually wants in it. I think it actually can do it. If it doesn't ask you for a decimal and it allows you to put in a fraction, put the fraction and you're going to get it right. So yes.
Did you think the equation for the p-hat looked back up?
It's the same thing. It's just x divided by n.
Oh, okay.
It's just a small n because we're looking at sample instead of per population. You're going to see that a lot when we start talking specifically about doing calculations and stuff like that later. They're going to be the exact same set letters, or just a lowercase letter for the samples instead of the uppercase letter for the population. How many people in here are left-handed? 2. I'm sorry, you live in a right-handed world, unfortunately. Everything is like designed that way. All right. What percentage of Americans certainly would not be able to produce $2,000 in the event of an emergency, according to this study? So how many people certainly wouldn't be able to do it? 532 out of 1,900. So what's the percent? Was it? That's okay. Did everybody get somebody? What else did somebody else get? You did it backwards again. So when you're doing a fraction, always put it in the order that it's listed. The problem is that you get like our mindset is always big number always first. It's like when you're looking at a fraction, we want it as a decimal, so we want something less than 1. So just keep that in mind. If you get something bigger than 1, probably did it backwards. So it's better to make those mistakes now than on the test and stuff like that, like to be able to realize that stuff. So not a problem. All right, so 28 or 28%. Okay, what percentage would probably not be able to pay a $2,000 bill in 30 days? So what did you divide? And what did you have? 0.22 or 22%? What if I told you the answer to B was 50%?
Oh,
Why? Go ahead.
If they if they probably can't, the people who certainly can't pay it are also included in those who probably cannot pay it either, so, like,
Yeah, the answer to this question actually is 22%. However, when you're looking at questions, sometimes you have to read what they're asking you. So if I probably couldn't pay it, the people who certainly couldn't pay it also probably wouldn't be able to pay it either, right? So depending on how you think about this question, you have to add those two together and divide it, which will give you approximately 50%. Yeah.
I have to look at what they're asking, because there's like the quotations around probably, that
Yeah.
suggest that sample.
Yeah, I believe in this question it is actually 20%. I don't have the answer to it, but because of the quotations, they're probably specifically just looking for that one. So what does it say about the saving habits of Americans? And I remember it was actually done a while ago. It's probably way worse than this now.
Yeah, it definitely would.
So
Over 50% can't come up with.
yeah, I think I saw the other day that credit card debt in the United States has passed like almost $2 trillion. So it's not good.
$500,000 bill.
Yeah, it's not good. So, and if any of you have pets, a $2,000 vet bill is not out of the realm of possibilities for us to be. I got my dog. The first thing I got was insurance, so I didn't have to worry about that problem. Like, nope, not having to deal with this. So yeah, it's not good. All right. Any other questions? Because we are done with this.
Except the index card for Wednesday has to be 3 by 5.
Or 4 by 6. Yeah.